Okay, so this is where we left off last class. We started to actually calculate some probabilities, and a few things I want to remind us of. Looking at the 5 rules, we said that probability is always between 0 and 1. If we're looking at the probability of some event A, we're going to count up how many outcomes and divide by how many total. We talked about the probability of not some event, so sometimes it's easier to calculate not A than it is to calculate A, so we just subtract from 1. And then the last thing we ended with is the idea of mutually exclusive. So we said mutually exclusive and disjoint have the same meaning, but if events are mutually exclusive, they can't happen at the same time. In terms of a Venn diagram, these events A and B are mutually exclusive because there's no overlap. Whereas in green, the events are not mutually exclusive because they do have overlap, meaning those events can happen at the same time. All that we went through, you agree? Okay, great. So we are going to add on to that. We're going to start by looking at this example. In 2012, fans at the Arizona Diamondbacks home game would win 3 free tacos from Taco Bell if the team scored 6 or more runs. In the 2012 season, the Diamondbacks won 41 of their 81 home games, and they gave away free tacos in 30 of their 81 home games. In 26 of the games, the Diamondbacks won and gave away free tacos. Let W equals win and T equals free tacos, and we are choosing one home game at random. First thing that we are doing is summarizing the data in a two-way table. Okay, two-way table. What that means is there's 2 things that are happening, right? In this case, are they winning the game? Yes or no? And then, are they giving away free tacos? Yes or no? So one of those events will be one way on the table, the other event will be the other way on the table. Okay, so here's how we're going to display that. I need to give myself some room on either way of the table. Okay, so W means that they win. If they didn't win, that is, so didn't win, so that's not W, but of course there's some notation for that. We're not going to write not W. The way to write not W is W with a little C. That C means complement. The other way that you can write that is W with a tick mark. So either of these 2, when you see them, mean not that event. So not W, in other words, they did not win the game. So this is going to be they didn't win the game. And then either they gave out free tacos or they did not give out free tacos. Okay. So going back to starting here. In the 2012 season, the Diamondbacks won 41 of their 81 home games. So they won 41 of the 81 home games. So that 41 goes here. So they won 41 of those games. Sometimes they gave out free tacos, sometimes they didn't. And then we're told of their 81 home games. Well, we're only looking at home games in general. So that 81 is the entire total in the table. And then we were told they gave away free tacos in 30 of their 81 home games. So looking at free tacos, in total, that happened 30 times. Okay, and then lastly, it says in 26 of the games, the Diamondbacks won and gave away free tacos. So 26, they won and gave away free tacos, which is this part of the table. Now, we should have enough information to fill out the rest of the table. If they gave away free tacos 30 times, 26 happened here, which means 4 goes here. So there were 4 games where they did not win, but they still had to give away free tacos. Likewise, here, if I have a sum of 41 and 26 games happened here, the remaining 15 are going to happen here. Okay, and then if I subtract all of those from 81, that'll give me this part of the table right here. I haven't done that yet, though, which is 36 games. So that's our table. question. Okay. So, part B, find the probability they did not win the game. So denominator of that is going to be all of the possibilities. So that's going to be 81. And then in the numerator is how many times they didn't win the game. Well, they didn't win the game here or here. So 40 games total, they didn't win the games. 40 times total, they did not win. So the probability they didn't win the game is 40 out of 81. And you can leave it like that. If you want to convert it to a decimal, great. You have to, at a minimum, though, show the fraction. Do not give your answer as a percent, please. C, find the probability that they won the game and that there are free tacos. Again, that's out of all 81 games. When did they win and give away free tacos? Well, that happened 26 times. Okay, and then D, find the probability that the Diamondbacks win or there are free tacos. So if we look in the table, they win or there are free tacos happened here. There's free tacos. Here they won a game. So it's all three of those. So out of the 81 games, 26 games and 4 games and 15 games. So that gives us 45 out of 81. So that is the probability that they win or that there are free tacos. Okay. Now, the question is, if I'm looking for the probability that they win or that there are free tacos, can I take the probability that they win and add the probability of free tacos? So are those going to be the same? Well, let's calculate that. What is the probability that they win? How many times did they win? 41, right? Okay, so 41 out of the 81 games. How many times did they give away free tacos? 30 times out of the 81. So the question I asked, can I take the probability of winning and add the probability of free tacos? Well, that's these two. If I add those together, am I going to get the correct answer? We should see no. Right, so this is the correct answer. If I add these two, though, I do not get 45 out of 81. Do we know why? Oliver, what do you think?
Because there's overlap.
Okay, do we see that there's overlap? So the probability of winning is here. Probability of free tacos is here. So do we see that these games get counted twice? That those 26 get double counted? So that is the issue with just taking these two and adding them together. Do we remember when we're allowed to do that, though? When would that work?
If they're mutually exclusive.
Right, if there is no overlap, if they're mutually exclusive. Okay, so let's write down what we just said. If events are mutually exclusive, if we remember, that means they cannot happen at the same time. So then, if I'm looking at the probability of A or B, I take the probability of A and I add the probability of B. Only though if the events are mutually exclusive, if they cannot happen at the same time. In the case of what we did in D, that the Diamondbacks win or that there are free tacos, those can happen at the same time. Right? The team can win and give away free tacos at the same time. That happened 26 times. So the general addition rule, generally, if I want to find the probability of W or T, I'm going to take the probability of W, I'm going to add the probability of T, but then these 26 games got double counted. They were counted twice, so we have to take them out once. So I'm going to be honest. I don't really know why you learn this stuff in red. What I just put parentheses around, I don't think you really need to remember, because you can understand that just from here. If the events are mutually exclusive, if they can't happen at the same time, then the probability of them happening at the same time is just 0. So that's not something to remember. What you need to remember is in blue right here. This part is what is incredibly important. Questions? Okay, I want to talk about a few other ideas. The first thing is I want to talk about, Veronica, yes?
I'm confused with the wording. So why wouldn't it be P of W plus T equals P of W plus P of T? Why is it or?
Here,
Yeah.
ask your question again.
Why is it W or T and not W plus T?
W plus T doesn't mean anything because we're thinking like W and T like they're variables. They're not though. They're events. So saying wins plus free tacos just doesn't make sense in terms of events.
Okay. But then, so does that mean, I guess I just am confused why it says or. Does that mean that P of W equals P of W plus P of T?
No. This means this is the probability that this event happens or this event happens. So I go to a game and either the team wins or I get free tacos. One of the two happens.
But you're still adding them together?
Yes. Give me 5 minutes.
Okay. Yeah.
We're gonna look at a Venn diagram to help us see this in a picture, and then hopefully that will help clarify what exactly I'm referring to. Okay, a few things we need to talk about. We need to take a look at some Venn diagrams so that we know exactly what we're referring to. And then the other thing that I want to do is talk about notation. Most of the time, this is not going to be written out in words. There is a symbol for or, and there is a symbol for and that I want us to know. I, from now on, will not be using the word or. Instead, the word for, or the symbol for or is like that. Likewise, I'm not going to use the symbol, I'm not going to use the word and. The symbol for and goes like that. Okay. We are going to do some Venn diagrams, and then we will come back and keep talking about this stuff. Is that okay? So let's keep going off of these notes. This is most of what your homework is going to be. Just reading numbers out of a table. Occasionally you'll have to make the table, but just drawing numbers out of a table. The next few things are, I don't think are in your homework, but they will be coming up. So any questions for what, before we keep going? Okay, let's talk about E. Find the probability that the Diamondbacks win the game given there are free tacos. So this is a really big deal. Given there are free tacos. What that means is we're only looking at the 30 games where free tacos were given out. So we're only looking at this row right here. So given the 30 games where free tacos were given out, in how many of them did the Diamondbacks win? 26. That's it. Leave your answer like that. If you want to simplify, great. I wouldn't because I'm lazy. So then in F, find the probability that there are free tacos given the Diamondbacks win. So this time, we only care about the Diamondbacks won. So if we look at the games where they won, there were 41 games where they won. And out of those 41, how often did they give out free tacos? 26 times. Now, I want to show us how to put that in notation. So if it says, given the Diamondbacks win, this is the way to show that. So, given the Diamondbacks won, what is the probability of free tacos? It goes like that. Whereas in E, given free tacos, what is the probability of winning? So what I hope that we notice is that these notations are different. So same variables, but they were flipped, and that affected the answer. So if we flip our two events, that does change the answer. That is called a conditional probability. So that is called a conditional probability. So a conditional probability is looking at the probability of an event knowing another has occurred. So something like this. That is saying find the probability of A if we already know that B has occurred. Okay, if you think back to chapter 1, I'm not going to write this down on our notes, but we'll just talk about it. If you think back to chapter 1, we did things like stacked bar graphs. There was one about pizza toppings that you guys did on a test, and it was something like this. What are people's favorite pizza toppings? And let's say we're comparing your class to the other class. And in your class, there's this many people that like pepperoni, this many people like sausage, this many people like cheese. But in the other class, they really like pepperoni, they're not a big fan of sausage, they like cheese. This is a conditional probability. This is the condition of either you're in block 7 or you're in block 8. If you're in block 7, what's the likelihood that you like pepperoni? It's a similar idea. Okay, so, in terms of a formula, we know that B has occurred. So B has to go in the denominator. Right, so similar to what we did up here. We know that the team won the game, so we're looking at only the games that they won. We know that free tacos were given out, so we're only looking at the games where free tacos were given out. The numerator then is 26 is where both happened. Same thing over here, that 26 is where both happened. So this is the probability of A and B. Questions? Okay. We're going to finish this and then I need probably 10 more minutes and then I'll try to give us a break. Okay. All of these are different. So we have mutually exclusive, we have conditional, and the last thing to talk about is if events are independent. Two events are independent if knowing the outcome of one event doesn't provide additional information about the other event. Thinking back to these pizza toppings on the board, if I were to ask you, is there a relationship between the class you're in and your favorite pizza topping, what would you say? Yes. Do you remember talking about how the distributions look different? And so if I told you that someone was in block 8, they're way more likely to like pepperoni than if they're in block 7. All that sound familiar? Same idea. It's exactly the same idea. So in the Diamondbacks example, are the events T and W independent? Well, the probability of T, the probability that they gave away free tacos, that happened 30 times out of all 81 games. And this time I'm going to give us a decimal because we're going to need that. It's about 0.37. Now, I want to know, though, if I know that the team won the game, does that give me more information about the free tacos? So if the team won the game, does that give me information about the free tacos? So that's above. That's the 26 out of 41 that we already found. That is about 0.63. So what we see here is that the probability of free tacos is not the same as tacos given a win. So the probability of free tacos in general is just 0.37. But as soon as I tell you that the team won the game, the probability that free tacos were given out is significantly more likely. It's significantly higher. So if you know that the team won the game, that gives us extra information. Way more likely that free tacos were given out. So what does this mean? That tells us that events T and W are not independent. If I tell you that the team won, that changes the probability. Okay. Questions for me? Okay, at this point, I want us to do a little bit of practice. And so if you flip to the next. Okay, so let's say that we have these two events, win and free tacos. So here's how those two events would look. Okay, so I want to shade some various things on this Venn diagram so we know what we're referring to. If I were to shade this part right here, those would be all of the games where the team won and people were given free tacos. So again, that's what this means. This is and. So the team won and people were given free tacos. That's where the two overlap. Now, similar idea. If I'm looking for W, if I'm looking for all the games where the team won, that is all of this. Now, people will say, well, why did you shade the part in the middle? I shaded the part in the middle because the team still won there. They also had to give out free tacos, but I don't care about that. I want all the games where the team won. Okay. If we look at all of this stuff, there are games that exist out there that's called the universe. All of the games in the universe, the team didn't win. They also didn't give out free tacos. So that would be where the team didn't win and they didn't give out free tacos. Okay, the or is the one that is most confusing. It is not a strict or. So if I'm saying the team won or they gave out free tacos, that's all of this stuff. That's any of the games that fall in what I shaded. So that includes the team won, but they didn't give out free tacos. Free tacos were given out, but the team didn't win. Or that still includes both happening. So a lot of people don't recognize that this is here. So if I say the team won or free tacos were given out, that still allows the possibility of both. Now here's what we should see. In this Venn diagram, I would take the probability of W, so that's this stuff right here, and then I would add the probability of T, which is this stuff right here. And what I hope we can see is that this part in the middle was counted twice. That's why we have to take out the and. It's because it occurred twice. Okay, Veronica, back to your OR question. Do you want to talk about OR some more? Do we have a better grasp of what I mean by OR?
Yeah, I think I
Have a better understanding. Okay, I'm not going to be forcing us to use these. I think it's helpful sometimes to conceptually understand what we're talking about. Okay. Questions for me? Okay. Page. Oh, not that one. This page. We're not going to do the stuff at the top right now. What you're going to do is this question. So it's very similar to what we just did. You're going to create a two-way table, and you're going to answer some of these, well, all of these questions. You're going to need a calculator, so with the person next to you, there you go. Sorry, one thing. I'm going to define variables for us. Let O be that the person is a homeowner, and let S be that the person is a high school graduate. So I want the table, and then for all of the probabilities, not only do I want the fraction, but I also want probability notation, please. So with your group, take, 5 minutes, and then we'll come back together. Here's what I got. So first of all, did you get the right table? It looked like most of you did, which is great. It looked like we had a lot of the correct answers, which is also great. I am concerned that we have the right probability notation as well, because I expect us to have notation for each of these. Now for E, find the probability that a randomly selected high school graduate. So that's a given. We're only looking at high school graduates. Out of the 310 high school graduates, how many are homeowners? That's 221. And then for F, that's not the only way to answer that. I wanted to do the least amount of work possible, so I wanted to use the probability that I already had. I already had the probability of O given S. Now, if the events are independent, then the fact that S happened shouldn't matter to me. So this probability should just be equal to the probability that the person is a homeowner. So this I had to calculate. That I just took off of the table. Because these numbers are different, even though they're a little bit close, that doesn't matter. Because they're different, we say that our events are not independent, or they are dependent. How we doing?
This might be a dumb question, but
No.
on the table where it says like homeowner, not homeowner, like the little labels, does it
Yep.
matter where you put them?
Nope. Bless you. Anything else? Michaela?
I just had like a question on why it would be homeowner over high school graduate, not like high school graduate over homeowner.
Are we talking about E?
Yeah.
So, randomly selected high school graduate, that's our given. So that is the part that we know happened.
Oh.
We know we're only looking at the high school graduates. Okay, I just want to return to the top of this and do those two tables, and then we will be done with notes. So a lot of people mix up the idea of mutually exclusive and independent. These are completely different ideas, and they cannot happen at the same time. So events can be mutually exclusive, they can be independent, they can't be both. And it's possible to have two events that are not mutually exclusive, nor are they independent. Okay, mutually exclusive, in my opinion, tends to be the easier one. It means that they cannot happen at the same time. So in our table above, A and B cannot happen at the same time. There's a 0 here then. The rest of the table then should be pretty easy to fill out. That means that I have 30 here, and I have 60 here. And if I subtract everything from 100, 10 is what remains. Now, independent, completely different. And this is the one that's going to require a little bit more effort. Independent, like we wrote on the previous page. The probability of A given B, if events A and B are independent, then it doesn't matter that B happened. I should still just get the probability of A. So again, this is saying if B happened, that doesn't mean anything to me. It's still just the probability of A. Well, if we look on the table, what is the probability of A? What's the probability of A? $60 out of total of 100. And all we're just looking at is the whole A column right here. Okay, on the other side, we know that B happened. So we know that B happened. B only happened 30 times. I want to know what is the probability of A. That's this number right here. So B happened. Out of the B, how often did A happen? That's this number in the table right here. And then you're just cross multiplying. That X ends up being 18. So this number is 18, and then you can fill in the rest of the table. So this would be 12. This would be 42. This would be 28. So again, these are different ideas. Cannot be both at the same time. Questions for me?